Hello class, this is just a continuation on calculating the equation of a tangent as well as calculating the equation of normals. In the previous video we saw that we could utilize the point gradient formula as well as the derivative in order to find the equation of the tangent. In this video we're going to be looking at calculating the equation of the normal. Well, since we already have the derivative from the previous example, let's use this again because we still need to find the the gradient of these tangents. Let's also just copy this one down just so that we remember how to utilize it. So here we go. To find the equation of the normal, we're still going to be using the point gradient formula. So we still need y1 and x1. But we also need the gradient. For this, let's find the gradient at x equals 0. Substituting this into the value, y prime equals -3 times 0 squared minus 3. So the gradient at this point is just -3. Here's where it changes a little bit. So this here is the gradient of the tangent. Since we're looking for the gradient of the normal, and the normal is perpendicular to the tangent, I hope you remember that if two lines are perpendicular, their gradients m1 times m2 should equal -1. So -3 is the gradient of the tangent. Let's let that be m1. So that's -3 times m2. Now, to find the gradient of the normal, we just solve for m2. m2 equal to +1/3. Now that we have this, well, I hope you saw it's actually very similar to this one. But now we already have the coordinates of the tangent. The coordinates of the normal will also be the same. Just to illustrate this, let's go back here. The coordinates of the tangent, actually no, let's use this one. The coordinates of the tangent are P, x1, y1. But notice how this also intercepts the same point. So we can just utilize the same points that we found in the previous example. So the coordinates we're going to use are 0, 0. Using now the point gradient formula, it becomes y minus y1. 0 equals m. The gradient is 1/3 times x minus x1. Disregarding the zeros, this becomes y equals 1/3 x. Doing this again, just as a quick shortcut, we actually already have the gradient of the tangent. So here we are. So this is the gradient of the tangent. All we now need to do is find the gradient of the normal. Once again, I hope we can recall that the gradients of perpendicular lines, when we multiply one gradient to its perpendicular line, we get -1. Since we already have 45 as the gradient of the tangent, 45 times m2 equals -1. Solving for this gradient, we get m2 equals -1 on 45. We also already have the coordinates of the tangent. So let's utilize this. And now we can just use the point gradient formula. This becomes y minus 52 equals -1 on 45 times x minus x1. It's x minus x1, which is 4. Expanding this, we get, let's use some more lines. This becomes -1 over 45x plus 4 on 45. Moving 52 to the other side, this becomes plus 52. So the equation of the normal is 1 on 45x. Evaluating this into our calculators, 4 on 45 plus 52. I'm just going to leave it as is there. So 2, 3, 4, 4 on 45. But as a decimal, -1 on 45 x plus 52.09. One last example. X equals 1. I believe we already have its normal. Here's where it gets slightly more tricky. We have the gradient as 0. So the gradient at this point is 0. Visually, this will look like so. So if we have a curve, if we find the gradients at, let's say, this point, it'll be horizontal. If we wanted to find a perpendicular line to that, let's do this in purple, it would actually be going straight down like so. If we try and solve this the way we normally would, using the formula, this one here, let's take a look at what happens. M1 times M2 equals -1. That's 0 times M2 equals -1. That just becomes 0 equals -1, which is not true. So instead, let's consider what we remember about linear functions. If a line is completely horizontal, isn't its x value going to intercept at the x-axis? Well, for this example, since it's x equals 1, well, this horizontal line, sorry, this vertical line must be x equals 1. So the equation of the normal here is just x equals 1. That one's a little bit more tricky. I hope you ask some questions in class. Hope to see you in the next video. Hope that gave you an insight into calculating the equation of normals. Best of luck.